Alright guys, welcome back to Underground Science, and in this video we're going to be talking about naming alkanes, okay? And so let's start off with an example, because we could list out the rules, right, and just memorize the rules and then do the examples, but that's going to be way too long. It's going to take way too long to actually learn and put in your brain. So what we should do is we should start with examples and then list the rules as we do the examples so we can remember it better. Okay, so let's just start off by an example first. So let's draw a 7-carbon chain, right? And off the, well, I'm not going to say, but off this carbon, we'll draw a methyl substituent, right? And so the first step when you're naming alkanes is to always start by numbering the longest chain, okay? So start by numbering the longest carbon chain. All right, and so let's finish writing this carbon chain. And what that means is that there are actually many ways that you could potentially number this chain, this carbon chain, right? So if I wanted, I can say, all right, this is carbon number 1, 2, 3, 4, and I can say that this right here is a branch, right, off the parent chain. The parent chain being this, but that would be completely wrong because that's not the longest. Remember what's in our rule, right? In our rule is numbering the longest carbon chain. Okay, and that's not the longest carbon chain what we just numbered. So if we were to find the longest carbon chain, let's say we number it like this: 1, 2, 3, 4, 5, 6, 7, right? So is that the longest carbon chain? Well, let's see, right? Let's try to number it in other ways. So let's try to erase all of these and find another way to number this carbon chain, right? So another way you can number it is 1, 2, 3, 4, 5, 6. Previously, when we just numbered it before this, we saw that the longest carbon chain was 7. Let's do it with another color. And that 7 we said was from here. 1, 2, 3, 4, 5, 6, 7. So obviously the orange numbering, right, is not the longest, so we can get rid of that. So far, the way we numbered it in green is the longest carbon chain for the parent chain. Okay, so let's draw this right here so it can be near the 1. Okay, so far this is the longest, right? But then you can also number it the other way. So you can also say 1, 2, 3, 4, 5, 6, 7, right? So both ways you get the longest carbon chain, the longest parent carbon chain, right, which is 7 carbons. But which way is right? Well, the next thing you got to focus on is, let's try to stay consistent with the colors, is you have to have, so after you identify your parent chain, right, so if we circle our parent chain in, let's say, gray, our parent chain is this, right? We just don't know which way to number it yet, but we know that this right here is our parent chain. That means that this is our substituent. That's a methyl substituent. So the second thing that we have to focus on is the substituent. The substituent should be on the lowest carbon number. What does that mean? So if we focus on the brown numbering, the substituent, right, this methyl substituent is, so for the brown numbering, the methyl substituent is on carbon number 3. But for the green numbering, the methyl substituent is on carbon number 5. So for the green numbering, the methyl substituent is on carbon number 5. Who's lower? 3 is less than 5. This means that the correct way to number it is starting from left to right, right? Because that makes you get the longest parent chain, as well as it makes the substituent on the lowest carbon number, which is 3. So now that we have that, right, we can name the molecule. So the methyl substituent is on the 3rd carbon, so that's 3-methyl, right? And we know that from our previous videos, 7 carbons long. What's our parent chain? It's a 7-carbon long chain, right? and those 7 carbons don't have any double bonds, don't have any triple bonds, it's only hydrocarbons. What is that? That's an alkane. Well, what prefix is related to 7 carbon long alkane? That's heptane, right? Or that's hept is the prefix, and the alkane name is heptane. So we have a 3-methyl and we have a heptane. So if we just combine that, the molecule we have above is called 3-methyl heptane. That's it, right? And so if we move on to another example, right? And this is just the basics, right? So if we move on to another example, we can do this much quicker now that we've gone over the previous example, right? So if we draw something like that and we number the carbons, we're going to have, or not yet, let me just draw the actual thing first. So let's say I have this. Right now, let's number the carbons. So what would be the longest parent chain? Okay, so what's one way we can number it? We can number it like this: 1, 2, 3, 4, 5, 6, 7, 8. Or we can number it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So those are the 2 main ways we can number it, right? So which one would be the longest? Or you can actually number it the other way too. So you can number it 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So these are the 3 main ways that we could number this chain, right? Maybe there's others, right? I mean, of course, we could number it some other way, but that would be like very wrong, since now we know that we're trying to aim for the longest chain. So right away we can eliminate the orange numbering, because that only ends up to be 8 as the longest carbon, while the gray and green numbering ends up to be 9. So we can eliminate the orange numbering, right? And so let's go ahead and erase the orange. And if we erase the orange, we're only left with 2 possible numberings, the green numbering and the gray numbering. And so both those numberings end up to be 9, which is the longest carbon chain in this case. So what does that tell us? We know that nonane will be part of the name, right? But now we have to decide, okay, what is the substituent and where is the substituent? Okay, so if we look at just in general, right, the substituent is this. And this is the substituent because it's coming off the parent chain, which we just numbered, which is 9 carbons, right? Okay, so now that we know that, we have to figure out which numbering is correct in order to actually come up with the whole name, right? So first of all, what's a substituent called, right? We should know by now that this substituent is an ethyl substituent because it's a 2-carbon substituent off of the parent chain. So now that we know it's ethyl, if we look at the green numbering, right, so this carbon right here is where the substituent comes off of. If we look at the green numbering, that's carbon 4 in terms of the green numbering, which is starting from here and going that way. So let's write that down. So for the green numbering, the ethyl substituent comes off of carbon 4. For the gray numbering, the ethyl substituent comes off of carbon 6, because the gray numbering starts here and goes that way. And 6 is right here, and that's the carbon number that the ethyl substituent comes off of. And the reason why we wrote these down is because we know we have an ethyl, we know we have nonane, right, as our parent chain. So what number is ethyl coming off of? What carbon number? 4 or 6? Well, we choose the least number. Remember from previously, we said we choose the least number in our name when we name the molecule, which would be 4, because 4 is less than 6. So that's why the end, right, the end name that we come up with will be 4-ethyl nonane. All right, so that's pretty straightforward, right? There are examples that's not, that straightforward initially, so let's look into that. So let's say we drew 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is an 8-carbon alkane, right? Now let's say I draw a substituent, though. I draw a substituent right here, and I draw a substituent right here. All right, so first thing when we're naming alkanes, we need to number the longest parent chain, right? So you could start here or here. Whichever way you start, you're going to end up with it being 8 carbons. Because, like, for example, right, let's just do it. So first let's start here, 1, 2, 3, 4, 5, 6, 7, 8. See, that's 8 carbons. And if you were to start from here, you would also get 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. So whichever way, it doesn't matter. Let's just keep the orange numbering for now, all right? So we know it's 8 carbons, so we know we have an octane, right? Now, what are the substituents and where is it coming off of? So we have an ethyl substituent here, okay, and we have a methyl substituent here, all right? So what if we can number it from right to left, we can also number it from left to right, right? Because remember that rule when we're naming alkanes, you want to number it. First, you want to number the longest parent chain, which we just did, and you want to number it so that the substituent in that alkane, in that longest parent chain, the substituent is coming off the lowest number carbon. So in this case, the lowest number carbon that has a substituent is 3, right? But then you see there's also a substituent carbon 6. So you want to number it the other way too. What if we numbered it this way? 1, 2, 3, 4, 5, 6, 7, 8. Now we have the methyl coming off of the third carbon, right? If we're following the gray numbering, and the ethyl coming off the sixth. All right, so let's write that down. So for the gray numbering, right? For the gray numbering, we have the number 6 carbon that has the ethyl, okay? So the number 6 carbon has the ethyl. And for also the gray numbering, right, we have the number 3 carbon that has the methyl substituent, right? And then if we go ahead and turn the tables and look at orange, right, the orange numbering, and if we look at the 6th carbon here, the 6th carbon for the orange numbering has the methyl, okay, and the 3rd carbon for the orange numbering has the ethyl. So now we've basically listed out everything we need to know in order to name this molecule, right? So you want to choose, first of all, we already have the longest parent chain, right, which is 8. Now you want to choose the numbering pattern that's going to make the substituent come on the least number carbon. So then would that be the orange numbering pattern or the gray numbering pattern? Well, what for the gray numbering pattern, right? Let's start with the gray one. What is the least carbon number in which there's a substituent? 3, right? So let's circle that. 3, which is a methyl. Okay, now let's look at the orange numbering pattern. Which carbon number, right, what is the least carbon number, I should say, that has a substituent? That would be also 3, right, because 3 is less than 6. And we're talking about the orange numbering. And so that would be right here, which is an ethyl group. Okay, so now which one do we choose? Well, you choose the one that comes alphabetically first. So E, right, comes before M alphabetically. So you would choose the orange numbering. So that would mean in your name, right, your final name that you do, you would have 3-ethyl as one part, right? And then you would have 6-methyl as the other, because we're following the orange. So you have 6-methyl. We're not following the gray because we just compared the two, right? On the least carbon is what you care about, on the least number carbon, which is 3 for both, right? Because 3 is less than 6. For the gray numbering, for the 3rd carbon, you had a methyl substituent, and for the 3rd carbon, you had an ethyl substituent for the orange numbering pattern. And we know that E comes before M in the alphabet, so that's why you choose the orange numbering pattern. So if we go ahead and erase the gray numbering pattern, because that's not the one we're choosing, then we're going to get the correct numbering pattern, which is the orange one. And now you can see that, so what we're going to go with is the 3-ethyl and the 6-methyl in our name. And we have an 8-carbon chain, right, which is an alkane. That's our parent chain. So knowing all this, the final name, right, will be, or the final name for this molecule will be 3-ethyl 6-methyl octane. So let's go and write that down. 3-ethyl 6-methyl, right? And writing in alphabetical order, so because E comes before M, and then you finish off with your alkane parent chain, which is octane in this case. So octane. So that's the molecule name, 3-ethyl 6-methyl octane. All right, and so we'll go over some more alkane naming examples in the next video. So I hope to see you guys there.